This is a test on circles and parabolas. So this will serve as a good review of what you're supposed to know about circles and parabolas and their equations. Please, if don't have a pencil or a pen in your hand as you watch the video, watch and learn how to do these problems, and then when after you've watched a couple, go back and redo the problems that you had to view and see if you can do them by yourself. That process of doing the problem by yourself is what transfers the information from your short-term memory to your long-term memory. So please do not skip that step. Okay, looking at problem number 1. Which of the following is not correct? So this is review, so obviously this logarithm stuff doesn't have anything to do with circles or parabolas. But remember that we used to do this. If we had the log of A plus the log of B, that was equal to the log of A times B. So addition reduced down to multiplication. Alright, so if I have the log of 4 plus the log of 9, then that should equal the log of 4 times 9, or log of 36. So A is correct. And by the same way, this should equal the log of 3 times 12. 3 times 12 is 36, not 15. So this one, the 15 is coming from just adding the 3 and 12. Well, you don't add the A and the B. When you condense, you multiply. So B is the one that's wrong. Okay? Glancing at the rest of these, when you subtract, you divide, right? So if I have the log of A minus the log of B, that reduces down to the log of A divided by B. So this should be the log of 18 divided by 9, which is 2. So that's correct. This would be the log of 6 divided by 6, which is 1. And this last one, when you have a number in front, it can become an exponent. And 6 squared is 36, so that one's also true. Okay, looking at number 2. Find the value of A in this equation. Well, let's start by rewriting this in exponent form. So start with the base. The base is A, so I would definitely bring that straight down. Now these two things are going to trade sides on this equation. So the negative 2 is going to come over here as a power, and the 16 is going to come over here. So this is what we have so far. Now our goal is to get A by itself. Now here's the extra step that you pretty much just have to memorize this as a strategy. If I want to get rid of this negative 2, I could raise this to the negative 1/2 power. Okay, so think reciprocal, because this is 2 over 1, so I'm doing 1 over 2. And then I'm keeping the same signs, because what you do when you raise a power to a power is you multiply, right? So this is like having negative 2 over 1 times negative 1 over 2. Now a negative times a negative is a positive, so that way the negatives cancel out. And the 2's and the 1's cancel out. You could think of it as 2 times 1 is 2, 1 times 2 is 2. So you're just going to get 1, like a to the 1 power, and you don't have to put the 1. So essentially all this cancels out when you do this. Of course, you can't just do it to the left side only. So if I raise the left side to the negative 1/2 power, then I need to raise the right hand side to the negative 1/2 power. Now we learned how to do this without a calculator, but first, on this test you had a calculator, so you were actually allowed to use your precious TI-30 XS Multiview. So let's go ahead and use it. So I could simply do 16 to the negative 1/2 power. And bam, it's 1/4. Okay, which is why the answer was E. Now, just while we're at it, because when we originally learned this, we learned how to do it without a calculator. So let's look at that. A negative power doesn't make anything negative. It drops you down to the denominator. So this would be like 1/16 to the 1/2 power. And we learned that 1/2 power is the same thing as the square root. And the square root of 16 is 4. So also that's why it's 1/4. Okay, looking at number 3. What is the condensed expression for this? Well, we learned that this coefficient can, in condensed form, becomes a power. And then, like we just reviewed on the problem number 1, when you're adding logs, you wind up multiplying. So this would be like natural log of x squared times 3, which would be, we would more tend to write as natural log of 3x squared. And oh look, that's C. Alright, number 4. We are to write the standard equation for the circle with a diameter that has these endpoints. Alright, so let's get a picture going. We're going to need a circle with a diameter. Okay, so here's your circle. Let's see. Let's get a diameter going. Alright, something like that will work well enough. Okay, somewhere in here there is a center. Let's just call it this right here. So anyway, we have these endpoints. So let's call this point over here, this will be our 2, -1. And this endpoint will be our 6, 5. Okay, in order to write the equation for this circle, we're going to need two things. We need the center and we need the radius. Okay, so that's what we're shooting for. Let's first find the center. That should be relatively easy. Alright, the center of the circle will just be the midpoint of these endpoints here, this segment. So to find the center, I'm just going to take the average of the x's and the y's. So I'm doing 2 plus 6 divided by 2. Alright, that's the average of the x's. And I'm doing -1 plus 5. Hold on. I'm doing -1 plus 5 divided by 2 for those y values. So this is 8/2 and 4/2. So this is going to give me a center point of 4, 2. Okay, so we found the center of 4, 2. Right away, that gives me the left side of the equation. So looking at the 4 and the 2, that means I will have x minus 4 squared plus y minus 2 squared equals. Now over here on the end of the model, we know it's always the radius squared. So we found the center. You can check that off our list. Now what we need to do is find the radius. Okay, so what I like to do is start by finding the diameter. Alright, we can find the distance the whole way across the diameter using the distance formula, right? So the distance formula is like this. And that's where we do x minus x squared. So for example, 6 minus 2 squared plus y minus y squared. So that would be 5 minus -1 squared. And this will give us the diameter. Let's put this in the old calculator. Okay, so let's see, square root And so we had 6 minus 2 squared plus, and then what do we have over there? 5 minus negative 1 squared. So that gives us 2 radical 13, okay? So that's the diameter. So the diameter is 2 radical 13. And of course the radius, we know that the radius, if the entire diameter here is 2 radical 13, then the radius, which of course is from here to here, will just be radical 13. It's half. Okay, so the radius is our 2 radical 13 divided by 2. Okay, so our radius is radical 13. Now, of course, in the formula, it's radius squared. So we will go ahead and square both sides. And so the radius squared is 13. Okay, and of course I'm squaring. If I square radical 13, I get 13. Alright, so that's why instead of r squared, I'm going to go ahead and put 13. And that's how you find the standard form equation based on this information. Alright, this one we're supposed to write the equation. This is number 5. Write the equation of the line tangent to this circle at this point. So you definitely should be drawing a picture. So it's mentioning a circle and a tangent, so you should draw yourself a circle and draw yourself a tangent. Okay, so there's a circle and a tangent. Alright, now this pink line is what we're supposed to be finding the equation of. Okay, so this circle is going to have a center and point of tangency here. The center, looking at this part of the equation, opposites, right? So the center is going to be -2, 1. So that's important. Now this point of tangency is also given at the point 3, 2. So all of this should be part of your picture. Now, so our goal is to find the equation of this pink line. Now, you know that when you write an equation of a line, it's like y equals mx plus b. But look, so check it out. This is a 4-step process. Alright, step 1. We can't find, look, hold on, let me say this again. When we write the equation of a line, it's like y equals mx plus b, right? So that means we need 2 things in order to write this equation. We need the m and we need the b. So it's going to be like y equals something x plus something, okay? And this right here is the slope, and this right here is the y-intercept. Okay, it's the m and the b. These are the 2 things that we're looking for. So our first job is to find that slope, but we can't find it directly, so we're going to have to start with the slope of the radius. Okay, once we get the slope of the radius, then we can find the slope of the tangent. So that'll be step 2. Alright, slope of tangent. Okay, once we have the slope of the tangent, then we need to find the y-intercept, because then we'll have the slope of the tangent. Then we need the y-intercept, so that'll be step 3. Alright, so step 3 will be to find b. Okay, we'll find the y-intercept. And then the final step will be to write the equation. Kabam! So these are the 4 steps to finding the equation of the tangent line. So let's get started. So step 1, let's find the slope of the radius. Well, the radius is right here. Alright, if I want to find the slope of that radius, I will use the slope formula, which is like y minus y over x minus x. Okay, you could say y2 minus y1 over x2 minus x1 if you want to be more precise. But just make sure you do your subtraction the same way twice. So if I do 2 minus 1, for example, for my y's, for my x's, I must do 3 minus negative 2. But for the record, I could have done 1 minus 2 and negative 2 minus 3 as well. Alright, anyway, now, some of you do not know your arithmetic, and 3 minus negative 2, that just blows you away, and also with negative signs and such. So if you're getting wrong answers on a regular basis, you're doing recovery or something, I would recommend double checking your steps by using the calculator. So 2 minus 1 over 3 minus negative 2. Okay, 1/5. Alright, don't get it wrong because you messed up on your signs or something. We'll let your calculator help you. Okay, so now we have the slope of the radius. Let's find the slope of the tangent. Well, the slope of the tangent is just going to be opposite and reciprocal to the radius. The reason why is the radius is always perpendicular to the tangent. And hopefully you learned a couple of years ago that when lines are perpendicular, their slopes are opposite and reciprocal, meaning like if one has a slope of 2/3, the other will have a slope of negative 3/2. Opposite meaning opposite in sign, reciprocal meaning like the fraction is upside down. So that's what we're dealing with, opposite and reciprocal. So this is positive 1/5, so that means the tangent line will have a slope that is negative something, and then the reciprocal of 1/5 is 5/1, which is just 5. So the slope of the tangent is negative 5. Okay, so far so good. Now let's find b. Now the way we find b is in our minds we think about y equals mx plus b. Now we're going to substitute values for y, m, and x and use them to find b. Now the m, of course, is the negative 5, the slope that we just found. So all we need now is y and x. Now when they give you a point, they're giving you an x and a y. Okay, a lot of kids get confused about am I supposed to use this point, the negative 2, 1, or am I supposed to use this point, the 3, 2? Well, just always remember what our goal is. We're supposed to be finding the equation of the line tangent to the circle, the pink line. Which one of these 2 points is on the line? Only the 3, 2 point is on the line. So that's the only point that's going to help us find the equation of this line. So we would not use the center of the circle. It is not on the line. So I'm going to use 3 for my x and 2 for my y. So if I substitute those into y equals mx plus b, it becomes 2, because that's my y, equals m, so that's negative 5, and then x is 3, and then plus b. So that's 2 equals negative 15 plus b. Okay, so I would, of course, add 15 to both sides. Alright, to get b by itself. So that gives us 17. Alright, so in the end, we find that b is equal to 17. Okay, so we found the slope and the y-intercept. So the slope was negative 5, so that goes here. The y-intercept was 17, so that goes here. So that means we can go ahead and write the equation, which was y equals negative 5x plus 17. Okay, that is how you do number 5. Alright, let's take a look at problem number 6. Graph the equation of the given conic section and identify the important characteristics. So we're mentioning center and radius. So this is a circle. You can tell because in the circle your x is squared and your y is squared. So the center, well, we just look at it and we know that it's going to be the opposite of these. So that's negative 4 comma 2 will be my center. So we might as well go ahead and graph that. So negative 4 comma 2 would be right there. Now the radius. So this 16 is my radius squared. So that means my radius is 4 square root. Okay, so the radius is 4. That means I could go 4 in all directions from the center, and that shows me where the circle is. So there you go. Okay, and that is it for number 6. Pretty easy. Alright, this is a parabola. You can see the x is squared, the y is not squared, it's a parabola. So let's first decide, does this open up, down, left, or right? Well, we know that the first parabola we ever learned about was good old y equals x squared, which was an upward facing parabola. So that tells us that any time x is squared, it's either going to be up or down, depending on whether it's positive or negative. If y is ever squared, then that's when it's sideways. Now, in this case, the x is squared. So even though it's in parentheses with the minus 3, still x squared. So that lets us know that this is either up or down, depending on the signs. Now, the place you look for the sign is this negative 12. Because that's negative, then we know that this is going to open down. Okay, and now the vertex. The vertex is going to be the opposite of this and the opposite of that. Now, so this is going to be positive 3 comma 0. So remember, when it's just a plain y, that's just like having like y minus 0. So that's 3 comma 0. So that puts the vertex right here, 3 comma 0. Now the focus. So the focus, we can find that if we have the p value. So let's go ahead and do that. So we know that 4p is going to equal this number in the front here. So 4p is equal to negative 12. Right? So dividing both sides by 4, we see that p is equal to negative 3. Now, we knew that the parabola would open down. So the focus will be down 3. That's what the p tells us. So from the vertex, we will go down 3. So 1, 2, 3. So here's our focus right there. So that is the point 3 comma negative 3. So let's record that. Your directrix should be the same amount but in the opposite direction. So it should be up 3. So if this is opening down, so if I go up 3, so my directrix will be horizontal up here. Okay, looking a lot like that. So the equation, horizontal lines are always y equals. So this will be y equals 3. Now the focal width. The focal width shows up right here, but width is always positive. So don't put negative 12. Just put 12 for the focal width. That tells me that at the level of the focus, the parabola is 12 wide. That's a total of 12. So that would mean 6 to the right and 6 to the left. Okay, for a total of 12 all the way across. And that is what allows me to go ahead and graph this parabola. And there you go. So that is the end of number 7. Alright, looking at number 8, this is another parabola. You can tell because it's y is squared but x is not. And but this one we're going to have to rewrite it in standard form. Okay, the previous problem, it was already in standard form with parentheses and everything. So we will have to complete the square to get the quantity squared, the parentheses, so we can tell what's going on. Now because the y is squared, then that's going to be the part that stays on the left. So I'm going to leave both of these y terms on the left. Now the unsquared x term needs to go to the other side, so I'm going to do that. So I'm going to have to add 16x to both sides to get it out of there. Okay, so this is going to become, alright, so I've got y squared plus 6y. I'm going to leave a space to complete the square later. And then over here I'll have 16x minus 25. Now let's complete the square. So half of the middle squared. Half of this is 3. 3 squared is 9. Because I'm adding 9 on the left, I have to be sure to add 9 on the right. So this is going to give me, now I can, anytime you complete the square, it is guaranteeing that it will factor as the same thing twice. Y plus 3 times y plus 3 in this case. Now over here I've got 16x minus 16. I just combine these like terms and I got negative 16. Now of course this, what we were shooting for is to write this as y plus 3, the quantity squared. Okay, we're getting into that standard form. But we will also need parentheses over here. So that 16 in the front, we need to factor that out. So that's going to leave x minus 1. Remember, when you're factoring out a common factor, you can think of it as dividing if you want. So in terms of finding what goes on the inside. So 16 divided by 16, that's 1. And 16 divided by 16 is 1 again. So you get this. So now we have written the problem in standard form. So we can look at it and know things. First of all, let's decide, is this opening up, down, left, or right? Well, because it's a y squared problem, instead of the usual y equals x squared, which would be up or down, the x is not squared. The y is squared, so we know that when the y is squared, that's when it's either left or right. And because this 16 is positive, that tells us that it's going to open to the right. Okay, so we're opening to the right. Now the vertex. The vertex will be the opposite of this and the opposite of that. So -3, +1. Okay, -3, +1. So there's my vertex. Now the focus. To find the focus, I'm going to need that p-value. So check it out. I know that 4p is equal to the 16. Alright, so if I divide both sides by this 4, so that's going to give me p is equal to 4. Now, I knew this was going to open to the right. So now that I know that p is 4, that tells me to go 4 to the right. 4 to the right of the vertex. So that's going to put my focus right here. The coordinates of that focus are 1, 1. Now the directrix should be the same amount in the opposite direction. So if I go 4 to the left, then my directrix should be right here. Okay, so the equation of that directrix. A vertical line is always going to be x equals a number. In this case, x equals -7. Alright, now the focal width. The focal width is always positive, by the way. So even if this were a -16, I would just put 16. And I'm imagining this sideways parabola, but the focal width tells me that at the focus, it's going to be 16 wide. So that means if I go 8 up and 8 down, then that should give me the 16 that I'm looking for. Okay, so there's my 8 up, 8 down, and so that gives me enough points to graph this parabola. Okay, there you go. Alright, number 9. Sketch the given characteristics and use the information to write the standard form of the parabola. So, okay, we're talking about a vertex and a focus. So we're talking about a parabola. Okay. Now, as far as writing the equation, before we can really do it, we need the rough sketch that they're talking about. So let's just do our very best. Okay. So here is my. So this could be my x-axis and my y-axis. Okay. So if I go -2, 2, that'd be like this, -2, 2. Okay, so I'd have so far a vertex is going to be around there. Okay, now my focus is at -5, 2. 3, 4, 5, 2. So my focus is going to be right here. Okay. Alright, so this was 2, and this is -2, and this is -5. So anyway, pretty much the point of this is if this is my vertex and this is my focus, and I always color code this to help me remember. Because you don't have the colors like I do, one trick that I use when I'm doing this in pencil is when I do my focus, I will often do my focus as an open circle. So that way, if I look away and get distracted and look back, I still can remember, okay, this is my vertex and this is my focus. So it's going to wrap around it like this. Okay, so maybe use a little Burton strategy there. but I've got colors, so I'm going to go digital with it because I'm a beast. But this you know. Okay, so the point is, I know the parabola wraps to the left. It opens to the left. So this is a sideways parabola, guys. So that means when I am picking which version of the parabola model to use, is it going to be the model with x squared, or is it going to be a y squared model? I'm hoping you know that we're dealing with a y squared situation anytime it's sideways. So this should be y minus, so let me just do this. So it's like y minus k, if you will, squared is equal to 4p times x minus h naught squared. So this is the model that we're going to be using. Now the vertex is your h and your k. So let's go ahead and put that in, okay? So the vertex is h comma k. So the y value of 2 is going to go in the y part of the equation. So this is going to be y minus 2 right here. So remember how it's kind of always the opposite. So this is positive 2, so I'll do y minus 2. This is a negative 2, so as an x value, it's going to become x plus 2 when I put it in the equation here. So it's kind of, I think of it as being the opposite. So x plus 2. So that gives us a lot of our equation. So we just need to have p, so we can get rid of this and put just a number. Now the p value is the distance from the vertex to the focus. Okay, so I'm hoping you can just look at this and see that the p value, maybe I should zoom in. Okay, the p value is right here, is a value of p equals 3. Right? 1, 2, 3. Except for because it's going to the left, you should think of it as negative 3. Okay, the bottom line is it's going to the left. So whatever you do with the p, this number better turn out to be a negative number. Okay, now whether you think of it as putting in a negative 3 for p, so we have 4 times negative 3, so therefore it's going to be negative 12. Or if you didn't really think about the fact that p is negative, and so at first you just put a 12, either way it's going to the left, so this has got to be a negative 12. So whatever you do, make it a negative number when it's going to the left. So anyway, that's it. That is the equation that we were looking for, and we did our sketch to help us get it. Let's move on to number 10. Alright, so we're going to do number 10 in a similar way that we did number 9. Let's get our sketch on. So here's my y-axis and here's my x-axis. Okay. So let's see. We have a focus at negative 2 comma 0. So okay, 1, 2. So here's my focus. Negative 2 comma 0. We have a directrix at y equals negative 2. So you have to look at this and know that y equals is always a horizontal line. So it's a horizontal line at negative 2. So okay, so that's negative 1, negative 2. This is also negative 2. So that means our directrix is down here like this. Okay. Well, this tells us the direction of the parabola right now. But specifically the vertex. See, we're always going to eventually need the vertex. So please remember that the vertex is going to be halfway between the focus and the directrix. So that means the vertex is going to be right here. All right, halfway between the directrix and the focus. Okay, so that tells us that our parabola is going to be wrapped around in this direction. Okay, so it's going to be doing that type of thing. But we also know the coordinates of our vertex are -2, -1. Okay, that's what's happening. So as far as the equation, because this is an upward facing parabola, is this going to be the x squared model or the y squared model? It's going to be the x squared model. So we're thinking of x minus h squared is equal to 4p times y minus k not squared. Okay, this is the version of the parabola model that we're thinking of. Because we know the vertex, we know the h and the k, right? So this is h and this is k. Okay, so the x value goes with the x basically. So this -2, when you put it in the equation, will become x plus 2. It's kind of the opposite. This -1 is going to become y plus 1. Again, it's the opposite. So that gives us the bulk of the equation right there. We just need p so we can replace this with a regular number. Well, remember the p is just going to be the distance from the vertex to the focus. And of course they're separated by only one little unit there. So right away we know that p is equal to 1. Okay, p is equal to 1. So that means what we have here is 4 times 1 is our 4p. So that's just going to be 4. So we can really just erase the p and just put 4. Now this is a positive one because it's upward facing. Okay, if this were down or left, it would be negative. So just make sure this is a positive number to go along with the fact that it's upward facing. And then there you have it. This is the standard form equation that we were asked to find. Okay, let's move on to number 11. Okay, this time they were nice enough to give us the sketch, so we don't have to make our own sketch. So that should make this pretty easy to do. This is an upward facing parabola, so that tells us that we will be using the x squared version of the parabola model. So x minus h squared is equal to 4p times y minus k not squared. We're looking at it and we can see the vertex. Okay, that vertex is, okay, it's right on the x-axis. So this is 3, 0 is my vertex. So that's my h and my k. So so this is going to become x minus 3. Okay. Oh, I thought I erased that. Let's try again. So this is going to become x minus 3 and y minus 0, right? Of course, I don't really need the minus 0. I'm not going to mark it wrong if you had the minus 0, but a mathematician would erase that and just leave it as y. So this is most of the equation. So we just need the p value so we can plug that in and just have this be a number. Since it's upward facing, I also know this is going to be a positive value, so I'm looking for a positive p right now. And look guys, the p value is just going to be this, it's going to come from this distance between the vertex and the focus. So I can see that the p value is 3 because of that. Okay, so the p-value is 3, so that means since p is equal to 3, I'm dealing with 4 times 3 right here, which is 12. So then there you go. X minus 3 quantity squared equals 12y is our equation. Alright, that is it for number 11. Once. Alright, number 12. Create an equation for the circle whose center is 4, negative 1 and radius is 2, 2 radical 3. Well, the center alone gives us the entire left side of the equation. So this is going to be x minus 4 squared, because the opposite of that, plus y plus 1 squared, the opposite of that. Now, of course, this will be equal to the radius squared. So I just need to figure out what do I get if I take this and I square it. Okay, I'm going to go ahead and use my calculator for this moment. Okay, so make sure you use parentheses. So 2 radical 3 squared. Yeah, without parentheses you will get the wrong answer, by the way. So that is 12. So the radius squared is 12, so I can just go ahead and put a 12 in there. By the way, to do that by hand, 2 radical 3 squared means 2 radical 3 times 2 radical 3. Now, 2 times 2 is 4. Radical 3 times radical 3 is just 3. And then, of course, 4 times 3 is 12. So that's how you really do it. Alright, anyway, number 13. Alright, we're supposed to write the standard form equation and then say some stuff about it. They're not telling us up front whether it is a circle or a parabola. That's why, if it's a circle, then we'll do center radius. If it's a parabola, we'll state the vertex. At a glance, you know this is a circle because it has both x squared and y squared. So it's a circle. To write it in standard form, we're going to have to complete the square. So let's put these x's together. So that'll be x squared minus 2x, leave space. And let's put the y's together. So that'll be plus y squared plus 6y, leave a space. This 1 is in the way, so let's just subtract 1 from each side, and we'll have negative 1. So now let's complete the square. Half of this is 1, 1 squared is 1. Make sure you add it to both sides. Half of 6 is 3, 3 squared is 9. Make sure you add it to both sides. So that is going to make this as x minus 1 squared, and then y plus 3 squared is equal to, now the negative 1 and positive 1 cancel out, and I've got 9. So notice that the sign comes from the middle. Negative 2, this will be negative. Positive 6, this will be positive. Okay, so that is the standard form equation. So the center will be the opposite of these, so that'll be 1, negative 3. And the radius will be the square root of this, so the radius is 3. And that is it. So that was number 13. Alright, on number 14 we're solving systems. Okay, there's 2 different versions, and of course I'm going to do them both, but let's start with this one. Now anytime you're solving these systems, you're either doing a substitution or elimination. Elimination is the one where we set them equal to each other, and we try to cancel out one of the variables. So I could do this one either way, but I think the most direct way is to use substitution. So for substitution, you need to get one variable alone. So for example, if I were to add 2x to both sides, so that would give me y equals 2x minus 4. So suddenly the y is by itself. So I could take this and now substitute it back into the other equation. So that's what I'm going to do. So the other equation, y squared minus 4x, will become quantity squared minus 4x equals 0. So I'm making this substitution. So in here I'll have my 2x minus 4. Now of course to square this, I can't just square the two parts. I need to do 2x minus 4 times 2x minus 4, right? That's how you really square something. So I've still got my minus 4x equals 0. So I'm going to be doing that double distributive property that we always do. So 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Negative 4 times 2 again is negative 8x. And negative 4 times negative 4 is positive 16. Okay, so that's all that. And I still have the minus 4x. I'm just bringing that down. Equals 0. So combining like terms. So I've got my 4x squared. Now I have like terms here, here, and here. All three of those are like terms. So negative 8 and negative 8, that's negative 16. But another negative 4 makes it negative 20. So I will have negative 20x. And then my plus 16 equals 0. Okay, I'm noticing that the greatest common factor here is 4. So I am going to divide all of these by 4. Technically, I'm even dividing the 0 by 4. So that's going to give me x squared minus 5x plus 4 equals 0. Now, I'm betting this is going to factor. X squared can only be x times x. 4 could either be 2 times 2 or 1 times 4. Looking at a middle of negative 5x, I'm betting on the 1 times 4 option. Okay, inner I have 1x. Outer I have 4x. To get a negative 5 out of it, I would need both of these to be negative. So that would make this negative and that negative. But that also works because a negative 1 times a negative 4 is a positive 4. Always check to make sure that's true. So we've factored it. Now once you factor, if you're solving an equation, you need to set these factors equal to 0 to get the solutions. So this is going to give me x equals 1, and this will give me x equals 4. Now these are not the final answers because we need the y values that go with them. So I'm going to make, see how much space. Alright, I'm going to make my little t-chart. So I need x's and y's. So alright, so my x values are 1 and 4. Now I need to find the y values. Well, remember, we had a y machine up here, and it was this, y equals 2x minus 4. Okay, so that makes this y equals 2 times 1 minus 4. That's just 2 minus 4, which is negative 2. And that makes this y equals 2 times 4 minus 4. Well, that's 8 minus 4, which is 4. Okay, so that means our final answers are 1 comma negative 2 and 4 comma 4. Okay, so that's the answer if you picked this pair of equations to solve. So this is still problem number 14. Let me just put this over here. Alright, if you pick this pair, so that this pair was all about substitution, was the best way to go. For this pair, notice that we have y squared, that's the same, and even the x's are the same. So they will cancel out when we set these equal to each other. So the elimination method, where you cancel everything out, would definitely be the way to go for this pair of equations. So they're both already equal to 0, so I can just go ahead and set these equal to each other. So y squared plus x plus 6y plus 8 is equal to y squared plus x minus 16y minus 14. Technically I'm subtracting y squared from both sides, but you know, when you see the exact same thing on both sides of the equation, you can just subtract them by crossing them out. And similarly, I will subtract this x from both sides. So that's just going to leave 6y plus 8 is equal to negative 16y minus 14. Notice how we only have one variable now, all y's. So that's always the goal. When you have variable on both sides of the equation, you should eliminate one of them and to move it to the left. So I will add 16y to both sides to get these y terms together. Okay, so that's going to give me 22y. Plus 8 is equal to negative 14. Of course, now I will subtract 8 from both sides. So that's going to give me 22y is equal to negative 22. Okay, so when I divide both sides by 22 to get y by itself, I come up with y equals negative 1. Now again, this is not the final answer. I need to I need to find the x value that goes with this. Okay, so far, I'm looking at imagining a t-chart. So I've got x and y. Okay, and I've got a y value of negative 1. But I would like to know the x value that goes with it. So what I will do is I will take my y value and plug it back in, substitute into one of the original equations. So I like the top one, just looks slightly simpler. So let's see, let me just carve out a little space. So here I go. I've got my y squared plus x plus 6y plus 8 is equal to 0. I just copied down that top equation. Now, substituting in the negative 1 for y, this becomes y squared plus x. No, I'm sorry. Forgot about the y squared as well. So I'm going to substitute here and here. Alright, let me just change colors for emphasis. So this y squared became negative 1 squared, and this 6y became 6 times negative 1. Okay, of course, negative 1 squared is positive 1. 6 times negative 1 is negative 6. Okay, so like terms. These three are all like terms. So 1 plus negative 6, that's negative 5. Negative 5 plus 8 is 3. So I've got x plus 3 is equal to 0. Subtracting 3 from both sides gives me x equals negative 3. Okay, so it looks like we have one solution here, which is negative 3 comma negative 1. Okay, so that is it. Now before we move on from this problem, let's go back and look at this graphically and see what these actually look like. Now looking back at the first pair of equations, you see that what we have here is a parabola with the y squared and a line. This is like y equals mx plus b. So when we're solving a system like this, we're finding the intersection of the parabola and the line where they meet. So look, I created a picture of it for you guys. So this is what's happening. We've got this parabola being intersected by this line, and what we found were the 2 points where the parabola and the line meet. Okay, and that was the negative 1, negative 2, and the 4, 4 were these points right here. Okay, so that's what that was all about. All right, let's take a look at a picture of the other pair. So looking at these two equations, we're looking at two parabolas, because you see the y squared and the y squared. So these are both parabolas. So let's see if we can visualize how these two parabolas could meet. And apparently they are only meeting at a single point, negative 3 comma negative 1. Alright, so here's kind of a close-up of the intersection of the two parabolas. And it's hard to see because of the way the software zoomed in, but you should be picturing the rest of the parabola. The blue parabola is doing this type of a thing, and the rest of the pinkish, reddish, purple, let's go purple. So the rest of the purple parabola is doing like this kind of a thing. Okay, just visualize that. So you can see that the intersection of those two parabolas right here is the one point that we found. And what did we say that it was? Negative 1, negative 3, or something like that. Let's take it was negative 3, negative 1. So this, we were finding this point right here, which is at negative 3, negative 1. Alright, I just wanted you to have a visual idea of what we're actually doing. Alright, number 15, last problem. A parabola has a vertex at 1 comma negative 3 and opens up. Given that 5, 1 lies on the parabola, what is the equation of the parabola? Alright, well, they tell us that the parabola opens up. So that means we will use the x squared version of the parabola model. So we're talking about x minus h squared is equal to 4p times y minus k. Alright, this is the model that we're dealing with. So, considering that the vertex is h comma k, then this becomes x minus 1 squared is equal to 4p times y plus 3 not squared. So it's kind of the opposite of these, like we've done many times before. So the only thing is we need to find this p somehow, and but this time we don't have a nice picture We don't have the focus. We don't have the directrix. We don't have an easy way to graphically find P. So instead, what we need to do is use this point that's on the parabola and substitute it in. Okay, so let's remember what we have so far. I'm going to kind of copy this over. So I've got x minus 1 squared is equal to 4p times y plus 3. Alright, I've got that in my back pocket. All I need to do is find p, and I'm golden. So the way I'm going to find p is I'm going to use this random xy that I'm given. But I'm going to substitute that in to what I have so far. So I'm going to take this. Alright, I'm going to take this x and then put it in right there. And I'm going to take this y and I'm going to put it in right there. Okay, so that's going to give me, alright, so I will have 5 minus 1 squared is equal to 4p times 1 plus 3 not squared. So notice I have everything except for p. So I should be able to solve this and I'll have p then. So this will be 4 squared is equal to 4p times 4. Well, that's 16 is equal to, and then 4 times 4 is also 16. Okay, dividing both sides by 16, of course, gives me p equals 1. Okay, so now I know that p equals 1. So if I put that back in, alright, p equals 1, then that just means that this is gone, right? 4 times 1 is just 4. So this is going to become x minus 1 squared is simply equal to 4 times y plus 3. And that's it. This is the equation that we were looking for. Okay, that's how you do number 15. And that is the end of this lesson. Please make sure if you're working on recovery or studying for a test, go back and make sure you can do every one of these problems by yourself. I helped you, you watched me, that's fine. But print out a blank copy, take out a blank sheet of paper, and go back and redo every single problem over and over again until you can get 100% without using the video. Then you'll be ready.